Hello, we are presenting our work on building a database for automatic speech recognition in Parkinson's disease. I am Professor Lori Ramig of LSVT Global, and I am joined by Dr. Bob McDonald of Google. The objective of this presentation is to describe the rationale and process for acquiring speech data to contribute to increasing accessibility to speech recognition for patients with Parkinson's disease. Disordered speech and voice may limit access to everyday voice-activated devices such as mobile phones, smart speakers, etc. These devices have automatic speech recognition systems that have been trained on non-disordered speech. This makes it frustrating for individuals with speech disorders, such as those accompanying Parkinson's disease, to utilize these devices. Project Euphonia is an initiative by Google to make speech technology more accessible to individuals with non-standard speech. For example, ALS, Down syndrome, stroke, cleft palate, cerebral palsy. The first step in this process is to gather large numbers of speech samples from disordered speakers in order to train speech recognition systems. This paper reports our initial work to collect speech data from individuals with Parkinson's disease to contribute to this project. Because of our over 20 years of research on speech and voice in Parkinson's disease, our research team at LSVT Global was invited to collaborate on Project Euphonia. After a series of pilot studies, procedures were established to optimize successful data collection supported by speech mentors. Screening procedures were established for technology, cognitive, motor challenges, and potential home support. Recruiting was expanded to include 8 major Parkinson's disease organizations. By completion of the final pilot study, over 75,000 phrases were collected from patients with PD, MSA, CBD, and PSP. Outcomes of the speech recognition data analysis are reported here. Looking to the far right in the circle, you can see that the word error rate was improved by approximately 80% for speakers rated as mild, moderate, and severe. We had a very limited sample of profound speakers, and there was only a 24% improvement there. Now, Dr. McDonald will briefly summarize the results of Project Euphonia from a larger group of individuals with non-standard speech.
Speech samples from more than 1,000 individuals with impaired speech have been collected for Project Euphonia. Our research aim is to improve automated speech recognition systems to better understand disordered speech, and our strategy is to build upon advances in end-to-end deep neural networks that have proven so effective at improving accuracy for typical speech. In this poster, we provide an overview of the corpus, which recently passed 1 million utterances. We also review key lessons learned, particularly those related to scaling data collections and effectively powering machine learning research. As of February of this year, our corpus includes over 1,300 hours of utterances from individuals with impaired speech. In fact, 579 individuals have exceeded 300 phrases. The utterance corpus spans a wide variety of disorders, etiologies, and severities. Some lessons learned include ensuring privacy and consent details are robust and clear. Critically important is active and continuous involvement with advocacy groups and individuals in these communities. Regarding the speech type and platform, our focus has been on scalability and transcript quality. This led us to prioritize prompted speech to enable high transcript accuracy. Samples were recorded from user devices rather than in a sound booth. The accompanying noise and acoustic artifacts were mitigated using a combination of manual and automated reviews. We kept participant burden in mind when constructing phrase lists, preferring shorter phrases over long paragraphs. These phrases span several domains that were chosen based on the use cases for eventual products that we envision, such as home automation or conversations. Progress in creating ever more accurate ASR models required increasing investment in quality control. The net result of the data and extensive machine learning research is a method for building personalized ASR models, where word error rate is reduced by 75% relative to the out-of-the-box unadapted speech recognition models. In fact, for over 80% of the personalized models, the word error rate was below 15% in the home automation domain. We present details about this ML research in a companion paper. We hope that sharing this information will allow other teams conducting research or collecting data related to disordered speech to more efficiently advance their work. And we'd really like to acknowledge the contributions from thousands of people and partnerships that have helped power this research.
Our conclusions and current goals for Parkinson's disease: a feasible data collection procedure has been established for Parkinson's disease, and the project will scale up to include larger numbers of patients, disorders, and dialects. Our target now is to collect data on 400 patients. In order to do this, we need to screen 1,000 patients. Thus, we need your patience. With that in mind, we invite you to join Google and LSVT in Project Euphonia to help individuals with Parkinson's disease gain access to automatic speech recognition. To learn more, contact us at either email or my personal email, and we'd be delighted to talk with you more about the project. In conclusion, we offer thanks to the Parkinson's community for their important collaboration throughout this work.